Hello, so this is the start of the second set of lectures for the machine learning module for World Quant University. So for the sets of lectures, we're going to focus on Scikit-learn. As we discussed before, Scikit-learn is the main Python package for machine learning. Yes, there are other packages that we might use throughout the course, but those are more for supporting roles. The main package we're going to use for machine learning is going to be Scikit-learn. So we got to make sure we are comfortable working with Scikit-learn, knowing its ins and outs, and how to extend its functionality. As you will hopefully see, working with Scikit-learn is rather easy and rather intuitive and quite fun, if I would add that as well. So let's make sure we have some baseline understanding, some great comfort working with this Python package. So what Scikit-learn is going to provide for you, it's going to provide basically two sets of things. It's going to provide you these machine learning models, that we'll use for our workflow. Additionally, it's going to offer us additional functions and tools that are necessary when we're doing a machine learning problem, so that's such that we don't have to always reinvent the wheel. For example, when you're working on a machine learning problem, it's customary that you do what is called a train test split on your data set. Writing out a quick function to do that is no problem. We should be comfortable enough to do that, but why reinvent the wheel? We can go ahead and use Scikit-learn's tools that it's going to provide for us. Right, so for this notebook, we're going to work on a famous housing data set based upon California. So what it is that it's data regarding the median home price for each census block in California. So let's go ahead and import that data set. One of the things that Scikit-learn does or has for us is already data sets that we can easily fetch and import for our analysis. So it's a nice way to try out some of these tools. We don't have to download a data set off the internet or find a good one to use. We can use something that's been used a lot for research and for analysis and for benchmarking, things like that. We'll be using this California housing data set. Let's go and import it. So we're going to import this function called fetch California housing that's going to fetch the data set for us. So this line is going to fetch the data set. It comes in a dictionary. So the observations are in X and the labels are in Y. So we can go ahead and print the description as well of this data set. Right, so if you look at this data set here, we see this data set has over 20,000 observations on 9 variables. Some of those variables include, if we look at the description, things like the average income, that's the average income of the census block. We have the average age, average homes, bedrooms, looks like the population, the average occupation, as well as the latitude, longitude of that census block. So the variable you're trying to predict, the 9th variable, is going to be the median home prices for that census block. Now, given what we have here, that we have over 20,000 observations and 8 degrees of freedom, or 8 characteristics for our observations, for our data set, how many rows do you think our data set has? Remember that for our data set, the rows are going to correspond to the number of observations. So we're going to have 20,640 rows. And for each of those observations, we have 8 characteristics, 8 attributes, 8 degrees of freedom. So we're going to have 8 columns in our data set. Now let me go ahead and open this up really quickly. Hold on. Find this useful at times. Remember, when working with machine learning, we have data in a structured form, or we want to put our data in a structured form. Sometimes it's not in a structured form, so we have to do something to get into the right format. If you think of, we have our rows, so these are our observations. Excuse my messy handwriting. These are the features or the attributes for each of those observations. So one row may correspond to a certain census block in California, and then there'll be different values across the columns that correspond to the average age of the houses there, the average home income for that census block. Those are all the attributes, features that describe all our observations. We have rows and columns, a matrix, a two-dimensional array. We also have our y. We call this our x. We also have our y. So y is our target, our label, and this is what we're trying to predict. So given the fact that we're talking about predictions, what type of machine learning are we doing? Are we doing supervised or unsupervised? We're doing supervised because we're trying to train a model with x and y to make predictions. So can we take these features for each of our observations and train a model to be able to predict this target variable, these labels? So to use this data set for training, we got to make sure for all our observations we have a corresponding label, a corresponding value we're trying to predict. So we're going to use this for our training purposes. So let's talk about how these machine learning models are implemented in Scikit-learn. What Scikit-learn is going to do, it's going to use a lot of object-oriented programming principles. So we've got to make sure we're comfortable with those principles, how to work with object-oriented programming, what is it all about. So Scikit-learn is going to implement these machine learning models as classes. And you can go ahead and construct a model by creating an object of that class. Now once you have that object, you can go ahead and train it and fit it and use it to make predictions. You can think of classes as representing a blueprint, a recipe that you use to construct an object. So you can use to construct an instance of the class. So for this example here, we're going to import the ridge model. So we're going to say it's located in the linear model module. So we're going to say from sklearn.linearModel import ridge. Notice anything peculiar, not peculiar, but different about the naming convention behind this class? It starts with a capital letter. And that's a very strong convention in Python, that custom classes start with a capital letter. And the first word of every word of the variable name starts with a capital letter. Hence, camel case. That's what it's called, camel case. So we had something longer like a logistic regression. The L will be capitalized and the R will be capitalized. That's called camel case. That's very useful because we can quickly look at a piece of code and understand what is a class. So let's create an object from that class. We can do so very easily. In this case, we're going to set a parameter called alpha equal to 0.1. So you might be wondering, what is alpha? Well, alpha is a hyperparameter to the ridge model. And hyperparameters are model parameters that govern the learning process. In terms of hierarchy, they're going to reside above simple model parameters. So they're set prior to learning. They're going to govern the learning process. They're going to govern the resulting values of the standard parameters, hence the name hyperparameter. Sometimes you might encounter the word metaparameter as well. We'll discuss more of these hyperparameters later on when we delve into these models. But they're mostly going to control this idea of bias versus variance. So we'll talk about that when the time arises. But you think of these as something we have to set for our model when we create an object from the class. Now within Scikit-learn, these machine learning models are referred to as estimators. Now there are different types of estimators. There are classifiers, regressors, and transformers. So a classifier and regressors, those are the machine learning models that make predictions. And we'll discuss what's the difference between the two later. As well as transformers are models that do some sort of transformation on a data set. So they're not going to be used to make predictions. programmatically what's going on is that in Scikit-learn, an estimator is going to inherit this base estimator class. It's the base class that inherits. And depending on what additional class it inherits, it's going to dictate whether it's a regressor, a classifier, or a transformer. So we have these mixin classes, the regressor mixin, the classifier mixin, or the transformer mixin. This will go ahead and differentiate what type of estimator this model is. We'll discuss these later on in this notebook. We'll play around creating our own custom classes for Scikit-learn. Scikit-learn does provide a lot of models, does provide a lot of functionality, but of course it isn't going to provide everything. So we got to be comfortable enough to go ahead and create custom classes to fit our needs, to fit our workflow. So we're going to make sure we have that level of comfort and familiarity to go and extend Scikit-learn by creating our own custom estimators. So make use of these base estimators, the regressor mixins, classifier mixins, and transformer mixins, depending on what we're trying to make. Think of it as a soup, right? You have the base stock. Depending on what you add is going to dictate what type of soup you have constructed. So I said before, within these estimators, you can group them up between the transformers or the predictors. The two predictors are the regressors and classifiers, which will we discuss next.